It is week 10 or week 1 of quarter 2. And today we're going to talk about combining like terms and the distributive property.
I was logged into the wrong account. I got it.
That's okay. I'm glad that it worked and it just popped up in my email. Woohoo! Okay, so today we are primarily going to simplify expressions by combining like terms and the distributive property. This is what is due this week. You have 2 math assignments basically, and then one of them is that math mindset thing, so it's totally doable. You got this. And remember, it's a fresh quarter, fresh start. So we can get it all done. Okay, do you guys remember, and you can type it in chat or you can say it, what are the steps to solving a 2-step equation? Do you guys remember? So like, remember how last week, oh, no, I don't want to do that. Last week we drew in a way to separate our equation from the left and the right, and then we kind of focused on where our variable is. That is one of the steps. That's going to be step 2. And I love how someone just volunteered an answer out there. Good job, seriously. So that'll be step 2. Step 2 is where we get rid of the coefficient by doing the opposite operation. And in this case, it is dividing. But sometimes it'll be a multiplying step. So in this case, you multiply or divide. That's very true. So if our second step is to get rid of the coefficient, what is our first step? So this one, this number in front of the variable is the coefficient. What was our first step? It's another C word, ends with ant. I like that. It's not can't. That's funny. I didn't even think of that. That's so good. Okay, it rhymes with onstant.
Constant.
Yay, very good. Ooh, that would be a better word. That's a good name. Constants. I like that. The second step is going to be get rid of the constant. Not right now, buddy. By doing the opposite operation. And in this case, it's going to be an adding or subtracting step. So that's what that one's going to be. Get rid of the constant by doing the opposite operation, either adding or subtracting. Good stuff, you guys. Good stuff. Okay, so today we're going to talk about the distributive property. And we want to know, what is the distributive property? So if I wrote this here, A times B plus C, do you guys remember what I would get if I used the distributive property? And it is in those foldables that we did, where we did all the properties. And we might not have had class that week. So I don't know if you guys actually did a foldable. So if you don't remember, that's okay. You did a foldable? Okay, good. Good. So Mom, do you guys remember? Get your boots on then. Do you guys remember what you would get if you used the distributive property?
Please help me.
I can't right now, buddy.
I need some help.
Oh, that's okay. That's fine. Hold on. I'm going to help my friend Logan here. Sit right there, dude. We're getting our boots on, even though it's cold outside. So remember, guys, remember the A is like the guy at the party who has candy, right? And he wants to share the candy with the B and the C. And we do that with multiplying.
I have such a dark brain. I thought that was going in a completely different direction.
No, it is not. You guys. You guys.
Not the same idea.
Oh my gosh, that's hilarious. Too funny. Logan, these guys are funny. Funny. Oh, we're getting our boots on. Aloha. Is that Lance the turtle? I like that. Get your coat on, buddy.
Stop stealing my brand.
What was that, Aiden?
I was literally zoning out and I hear them.
You heard the candy.
Yeah.
Like, what is she talking about? Okay. Oh, yeah. Yeah, no, I get that. That would be a little weird there. Okay, so distributive property is where you have a number in front of parentheses, and you're going to multiply it by each term inside the parentheses. So we would get A times B plus A times C. And then if you actually do the multiplication, you would get AB plus AC. So what would I get here in this example if I'm going to multiply the two? Logan, don't let the cat out. Close the door. Oh, you can put a hat on? That's smart. Okay, don't freeze out there. Oh, Cece, that's okay. No problem. Close the door, Logan. Close the door, dude. Just making sure Kitty doesn't escape into the frigid temperatures outside today. Okay. So, and guys, by the way, this should go without saying, but this is a really good thing to write down just so you have examples of it in case you need it. If you're like, I know the distributive property, I don't need this, then you don't need to write it down. Okay, but guys, let's refrain from the epic artwork. Even though it's really awesome, let's avoid that just because for some people it can be really distracting. Although the artwork is epic, I will admit that. Okay, so we're going to multiply the 2 by each number inside the parentheses there. So what do I get if I do that? It would look like this. 2 times 3x. Thanks, guys. I really, really appreciate that. Seriously, that's really nice. That's okay. And we can leave Lance there. It's all good. But just no further artwork. And this is hilarious. Cece's probably like, what? I gave a really weird example, Cece, of someone in front of the parentheses is like a guy at a party with candy.
And I took it in a completely different way.
Me too.
And someone, it was really funny. It was hilarious. Yeah. But, you know, it is. It's like you're going to share the candy. I did. Oh, my gosh. Sorry, guys. Share the candy. The guy with free Wi-Fi. There you go. That's another good one. Yeah, they're sharing the Wi-Fi.
No.
So we share with multiplication there. So 2 times 3x and 2 times 7. And then when I actually do that multiplication, I would get 6x plus 14. That's what I would get. So that's the main thing that we're doing today. And then we're going to combine some like terms. There's a few extras we got to talk about, but we will do that. Oh, how old is your puppy? I'm jealous you have a puppy. It's so cute. Okay, we're going to do this example here. Now, who's actually sharing the Wi-Fi here? What number is going to be sharing that Wi-Fi? Yeah, very good. That -9. Very good. Oh, Ray, that's so cute. Too cute there. So this 4x, because it's not in the parentheses, the 4x does not get any Wi-Fi. So they get kind of added on to the end. So we're going to share the Wi-Fi. So -9 times 2x plus -9 times 3. Don't forget to share with that other term there. A lot of people forget that one. So don't forget that. And then the 4x, they're not in the parentheses, so they just kind of get added on at the end. So now I'm going to simplify. What would I get if I simplify there? What do I get after I actually do that multiplication? Oh, good. I'm so glad. This is good. This will be a good little review. Wait, Logan. Oh, hold on. Okay, good. Good catch. Good job. Okay. Kitty tried to escape. Naughty kitty. Not catching her today. She can turn into a snowman today. So what would I get, guys? I'm so glad you've seen this. That's so good. We'll go through it quickly then. What would I get if you do the multiplication there? What do you guys think? What's that -9 times 2x? Yep, -18x. Great job, Kaden. You are right. Hold on,
That's
buddy.
me.
Okay, I'm going to grab the kitty for my son. Hold on one second. No more going in and out, okay?
Got it.
Come here, naughty kitty. I'm naughty. I like to run outside. She looks like a squirrel, doesn't she? I'll tell him you said hi. He's home today because we have to do a not fun test with him today. Give him medicine every, oh, I know, right? Every 30 minutes. So, yeah, that would be crazy. I don't think I could handle that. Not in this area. It's a little too busy. Thank you, Callie. Very good. -27. And then we have that 4x. Okay, so we've simplified, but we're not quite done yet. What do I have to do to fully simplify this one? It's kind of our other objective today.
You okay, Mom? So am I.
Oh, your mom is cold. Tell her I'm with her. It's freezing here today.
No, our house, like the entire house, is like freezing cold.
Oh. Okay, that is awesome. I like that. Okay, so guys, what is the other thing I have to do here? Gotta do something. I'm looking specifically at this -18x, and this 4x. Both of those have an x. So what should I say it again?
You multiply.
Oh, good. We're going to combine them. We wouldn't multiply them. You're right with the idea there. You guys are all right. You're saying we got to do something, but we'll combine them by doing what it says there. Because see what it says? It says -18x plus 4x. So what would that be if I combine them together? That's like saying I owe you 18 X's and I have 4 X's. Kaden and Cece, you got it. Very good. So that's like I owe you 14 X's. And then that -27 is at the end there. Very good. Yep, you would get -14x. Very, very, very good. So that would be right here. And then I can't combine any further because this one has an X and this one does not. So those are not like terms. Oh my gosh, Callie. That's crazy. Why is everybody texting me right now? Okay. Oh, ramen is good. Oh, that's crazy. Craziness. Okay. Any questions on this example? A lot of you guys are saying that it's what you've kind of seen already, which is really good. Okay, so now we're going to talk about combining like terms, right? So the whole idea is things that are alike have matching terms with them, right? Isn't this a cool example? So what are the like terms here? What?
3 and 2.
The 3 and the 2, right? Because they're both snowflakes. So I would combine them by doing either adding or subtracting here. You're not going to multiply or divide because it's just doing what it says, and you would get 5. Very good. So we would say 5. Oh, wait, I forgot. I don't have to write it out because, watch this. Bam! The 3 and the 2 both have snowflakes, so we combine them, and it is winter math. Yeah. And okay, I love how someone here wrote 9. I love that because I guarantee it many people are going to do that. Could we actually say 9 here? Could we do that? What do you guys think? Can I combine that 5 and that 4? No, Ayub, you're right. Cece, you're right. Good job, you guys. Ayub with the answer and Cece with the explanation. Woohoo! Very good. The 5 and the 4, they don't have the same terms, so we cannot combine them. And that is the most common thing to do. You just get in the habit of combining and combining, and sometimes it happens where you combine them and they don't have the same terms. So you gotta watch for those same terms there. Yeah, very good. So that's what we're gonna practice with right here. And I just want to go through some terminology. A term is a number or product of numbers separated by a plus or a minus. So this thing right here, see this 2x plus 7? This has 2 terms. Okay, it's got 2 terms there. So the first term is a product, right? Because a product is what you get when you multiply. And in this first term, we're multiplying the 2 times the x. So that stands for 1 term. And then the 7 is a constant that is just a regular number. And that goes with my other terminology here. A coefficient is the number in front of the variable. So for 4x, the coefficient is the 4. Right. Yep. I love how you put those emojis on there. Those are gorgeous. Now, guys, in this first one here, this 2x plus 7, which one's the coefficient there? What number is the coefficient? Is it the 2 or the 7? The 2. Yeah, you're right. And the 7 is the constant, the number without the variable. So what's the coefficient down here in this 3x minus 10? The 3. Yep. The 10 is kind of the constant. But guys, I have a question. What is the real constant here? This is a tricky question. What's the constant here? 1 goes for this one. Yep, 1 goes for that one. So we'll tackle that one in a second. What is the constant here? The constant is a number without a variable. So for 3x minus 10, that's okay. That's okay. That's totally fine. What is the constant? I'm going to say Caleb was the sorry, Caden. I said Caleb. Caden was the closest. Yes. And the person who wrote it in here yellow. Yay, yay, you're right. The constant would be negative 10. You got to use whatever sign is right in front of that number. So that's the tricky part. It's a negative 10. And then Cece, you had this one down here, the coefficient of just an x. If you guys just see an x there, if there's no coefficient in front of it, that coefficient is always a 1. Because there's one x there. Yay, winter math. What if eggs could use guns? Oh my gosh. They would fight us. We would never have eggs again.
They're probably, I don't know. You know, that's a little.
That would be sad. That would be too sad. Oh my gosh. I don't know what I'm talking about. Okay. They would. They would be like, you're not eating me today. Yeah. All right. Good stuff, guys. We're going to do some more examples and then we'll be done. So like terms have the same variable or the same, or they're both constants. Okay, so let's look at this first example here. Whenever you're combining like terms, what I like to do is I like to put ones in front of the regular, like the plain letters. And every time you see a subtraction, you guys see this subtraction here? Right here, this minus y. I like to change it to plus a negative. Because remember, every time you have a minus, so like if we have 3x minus 10, that's exactly the same as 3x plus negative 10. What I do is I add a plus in and slide that negative over to the term to the right. So in this case, see how there's a plain x there? What should I add in front of that plain x? What's the coefficient? 1. Very good. Yeah, Ayub, good job. And whoever wrote it in purple, yes. We would add a 1 in there. And then that minus, I'm going to change that to plus negative. And what am I going to put in front of that y? Yep. It would be another 1. Very good. It would be another 1. So it's almost like what I'm actually combining is 1x plus 2y plus 6x plus negative 1y. And then we're going to identify the like terms here. Yep, very good, very good. If I combine the 1x and the 6x, I get 7x. But I have one question here, friends, one question. I'm combining 2y, oh, this person's fixing it, very good, and negative 1y. What's 2y and negative 1y? It wouldn't be 5y. I like that. That's pretty. It would be just a y. That's right. Yeah, it would. It would be a 1y. Right? So put a 1y in there. My purple friend. Purple friend. Where'd you go? Purple friend stopped writing. Sad panda. Okay. So, oh, look at that. I just saw what someone, my camera was covering the emojis here. This is absolutely right. Very good. This person changed it to emojis. I think that's awesome. I love that. You can totally do that if it helps make sense. That's good. That's very good. So yeah, and if we kept it with the algebra language, it would be 7x plus 1y. Or you could just put y. Same thing. Cool. Oh yes, this person added a 1 in front of the z here. Very good. And what about that minus sign? What would that look like if I changed it to the plus negative thing? What would that look like there? What do you guys think? That 9 minus 3z, what would that look like if I changed it to plus negative? Oh. I don't know why he's banging on the window, Logan. You're so close, IU, but we still need that negative. Where would the negative go? You're absolutely right. It would be 9 plus 3z, but what turns negative then? The negative 3. Yeah, you're right. Very good. So it would turn into 9 plus negative 3z plus 8z plus 2 plus 1z. So then what am I going to combine here, guys? What would I combine? What are the like terms?
3 and 8.
The negative
And
3. Yep, you're right. The negative 3, the 8, and the 1. And when you combine them, you just go from left to right. So we'll first go negative 3 plus 8. What is that?
5.
That would be 5. Ayub, what you did is you did 8 plus 3.
Mom, so tired right now.
Okay. Just hang out, buddy. I'm almost done. We're doing good. We're combining terms, Logan. Yeah. Oh, that's okay. No problem. Everybody does that. Yeah. Everybody forgets about the negatives. You just got to be careful to not forget about them. So negative 3 plus 8 is like saying, I owe you $3 and I have 8 to pay you back. So we have 5 left over. Very good. This is pretty darn close there. Well, hold on. We'll see. Yeah, we'll have 5z, and then we got to add one more z. So we'll have 6 z's. And then what about 9 and 2? Yep, that's good. 9 and 2 would be 11. 6z plus 11. Very good. So guys, my suggestion here is don't forget about the negatives. Okay, be really careful there. And be careful you don't combine too much. Okay? Be careful, because a lot of people might go further and say 17z, but we can't do that here because this has a z and this one has no z. You guys are doing good. We're almost done. Almost done.
No.
Oh, we are done. Wow, look at that. We're too efficient, right? You guys are pretty epic there. That's all I had for today. Look at that. Guys, you did awesome. Nice work. Does anybody have questions about that? Wow. Guys, we were super efficient with that. Good stuff. Yeah, you guys are awesome. I can tell you've seen it before. That's very good. And if you encounter one that you have not seen before, that's okay. If you're like, hey, help me out with this question, because sometimes it's just the way it's worded. I know. I'll have to think of more to torture you with next week.
This is my favorite class. I don't like other classes. I like
Yay! I love
science. I like
you
this
guys.
class and science.
Oh, Leah's awesome. I don't blame you. Leah's pretty amazing.
She likes
She's
to pick on Aiden.
Does she really? Oh my gosh. See, I gotta go in and observe that class. That's awesome. That's awesome. That's cool. I'm glad. Aiden. That's too cool. No, you guys are so highly talked about by the other middle school teachers. You should know that. You are just a good reason to come and turn on the computer in the morning. Ooh, Callie has Snapchat.
I think I have her Snapchat.
Cool. Definitely exchange. I mean, it's
Like
really
when I first started, I was like, you know what? I want to make friends. So